In this question, we know that in the statement of the question, we know that p x1 equals to 0, and the result is 0.2, and p x1 equals to 1, and the result is 0.8. So uh, using in the A question, we want to know the probability of p x2 equals to 1. So from the base, we can know that p x2 equals to 1, and the probability is equals to p x 2 equals to 1 and x1 equals to 1 plus p x2 equals to 1 and x1 equals to 0. And because in the statement the conditional probability has been given, so we can use the conditional probability to calculate these two paths result. Because using the conditional probability, we can obtain that p x2 equals to 0 and x1 equals to 0, and the result is 0.12. And we also, using the conditional probability, we can know that p x2 equals to 1 and x1 equals to 0, and the result is 0.08. Also, p x2 equals to 0 and x1 equals to 1, and the result is 0.24. And also p x2 equals to 1 and x1 equals to 1, and the result is 0.56. So we can find that the result of the probability of p x2 equals to 1 should be equal to 0.56 plus 0.08, and the result is 0.64. And in the A question, we can also find that if we let p x2 equals to 0 and p x2 equals to 1, and if we let these two probability as a vector, and we can find that this vector equals to 0.2, 0.8, and multiple the matrix 0.6, 0.4, and 0.3, and 0.7. And this is very useful for the question below. In the second question, we in the B question, we want to know the probability of p x3 equals to 1, and p x3 equals to 1 can also be calculated by the base, so it equals to p x3 equals to 1, x2 equals to 1 plus p x3 equals to 1 and x2 equals to 0. From the conclusion above, we can also find that if we let p x3 equals to 1 and p x3 equals to we let p x3 equals to 0 and p x3 equals to 1 as a vector, and this vector can also be calculated by the vector p x2 equals to 0 and px2 equals to 1. Multiply the transmission matrix. And because the conclusion above, we can find that the result should be equal to px3 equal to 0 in px3 equals to 1, and this vector should be equal to 0.2, 0.8 multiple the transmission matrix to the power of 2. So we need to calculate the result of this this expression, and the result is 0.408 and 0.592. So the probability of px3 equals to 1 is 0.592. So this is big question. In the C question, we want to calculate the probability of probability of x3 equals to 1 occurring under the condition that x1 equals to 0 occurs. So using the conditional probability formula, we can obtain this equation that px1 equals to 0 and x3 equals to 1 divided by px3 equals to 1. And also from Bayes we can obtain this equation. Px1 equals to 0 and x3 equals to 1 equals to px1 equals to 0, x2 equals to 0, and x3 equals to 1 plus x1 equals to 0 and x2 equals to 1 and x3 equals to 1. Because in the statement of this question, we know that the condition probability has been fixed, and px1 equals to 0 equals to 0.2 and px1 equals to 1 equals to equals to 0.8. So we can find this chain as a Markov chain. And this means that the probability px1 equals to we can first we need to calculate these two paths result so that we can get the result of px1 equals to 0 and x3 equals to 1. And so the first part px1 equals to 0 and x2 equals to 0 and x3 equals to 1, and this equals to px1 equals to 0 multiple multiple the probability of x1 occurring under the condition that x2 equals to 0 occurs, and also and then multiple the probability of x2 equals to 0 and x1 equals to 0 occurring, and the condition that x3 equals to 1 occurs. Because what I have said, this chain is a Markov chain, so this part p x3 equals to 1, x2 equals to 0, x1 equals to 0, and this part equals to p x3 equals to 1 and x2 equals to 0. And so we can calculate the result. And also we can calculate the second part, p x1 equals to 0, x2 equals to 1, and x3 equals to 1, and this part is equals to p x1 equals to 0 and multiple p and x2 equals to 1, x1 equals to 0, p x3 equals to 1, x2 equals to 1, and x1 equals to 0. And also this part equals to p x3 equals to 1, x2 equals to 1, and x1 equals to 0. And the result is p x 3 equals to 1, x2 equals to 1. And so we can using the statement, using the conditional probability in the statement to calculate the result, and the result should be using this. We can know that p x1 equals to 0, x3 equals to 1, and the result is 0.2 multiple 0.6 and then multiple 0.4 plus 0.2 multiple 0.4 and in multiple 0.7, and the result is 0.14. So using the conditional probability p x1 equals to 0 and x3 equals to 1, and the result is 0.14 divided by 0.592, and the result is approximately 0.236. So this is the C question. In the D question, we want to find when n approaches to infinity and the probability of xn equals to 0. In order to calculate this expression, we need to first we need to calculate the result of the probability of p, the probability of xn equals to 0. And from the conclusions above, we can find that this factor pxn equals to 0 and pxn equals to 1, and this factor equals to 0.2, 0.8 multiple the transmission 0.6, 0.4, 0.3, 0.7 to the power of n. In order to calculate this part, we need to let A equals to the transmission matrix and um, and because we can find that the A is invertible, and we can using the diagonalization through similarity to represent the A, which is A should equal to P and multiple gamma, multiple P, multiple the inverse of P. And the gamma matrix is formed by the eigenvalue of matrix A, and P is formed by the eigenvector of the matrix A. So we need to calculate the eigenvector and eigenvalue of A. First, we calculate the eigenvalue of A, which means we need to calculate A multiple x equals to, and we use lambda to represent the eigenvalue of A, lambda x, and x is also a vector, so we can get this. In order to satisfy this equation, we need to let the determinant of A minus lambda multiple E, and this the determinant of this matrix need to be 0. So we need to calculate this 0.6 minus lambda 0.3, 0.4, and 0.7 minus lambda. And we need to calculate the determinant of this matrix, and the determinant needs to be 0. So we can obtain that lambda to the power of 2 minus 1.3 lambda and plus 0.3 equals to 0. So we can get that lambda 1 equals to 0.3 and lambda 2 equals to 1. Then we need to calculate the eigenvector of each eigenvalue. So for lambda equals to 0.3, the eigenvector is k multiple 4, and the x and the eigenvector is x in this expression. So when we have calculated the eigenvalue, we can use the eigenvalue to calculate the eigenvector, and so we can use this to calculate the eigenvector. And when lambda equals to 0.3 and the eigenvector is k multiple 4 minus 3, and k needs to satisfy this condition. Also, we can calculate when lambda equals to 1 and the eigenvector needs to be eigenvector is k 1 1, and k also needs to satisfy this condition. And then the gamma matrix is this, and P is and we also need to calculate the inverse of P, and this and the inverse of P equals to, and this has a formula, and so the inverse of P equals to 1 divided by the determinant of P, and then multiple the adjoint matrix of P. and the result is 1 divided by 7, and minus 1 divided by 7, and 3 divided by 7, and 4 divided by 7, and this is the inverse of p. And then we need to and then we can know that the matrix n a to the power of n equals to p multiple gamma and multiple the inverse of p and to the power of n, and this and this equals to p because we know that p multiple the inverse of p equals to e, and E is a unit matrix, so we can obtain the result is the result of matrix A to the power of n is p multiple gamma to the power of n and p and the inverse of p, and the gamma to the power of n equals to which is obvious 0.3 to the power of n and 0, 0, 1. And so we can we can obtain the result a to the power of n equals to this 4 divided by 7 multiple 0.3 to the power of n, and plus 3 divided by 7 and minus 4 divided by 7 multiple 0.3 to the power of n, and plus 4 divided by 7 and minus 3 divided by 7 multiple 0.3 to the power of n, and plus 3 divided by 7 and 3 divided by 7 0.3 to the power of n, and plus 4 divided by 7, and this is the result of matrix A to the power of n. So we can using this expression p xn equals to 0 and p xn equals to 1, and this vector equals to 0.2, 0.8 and multiple matrix A to the power of n, and we can calculate the result is 3 divided by 7 minus 1.6 divided by 7 multiple 0.3 to the power of n, and 4 divided by 7 plus 1.6 divided by 7 and multiple 0.3 to the power of n. And so we can find that the probability of xn equals to 0 is 3 divided by 7 minus 1.6 divided by 7 multiple 0.3 to the power of n. Because in the question we need to calculate when n approaches infinity, and this condition the probability of xn equals to 0, which also equals to when n approaches infinity, this expression which the result of this expression, and we can find that when n approaches infinity 0.6 divided by 7 and multiple 0.3 to the power of n equals to 0. So we can obtain the result is when n approaches infinity p xn equals to 0, and the result is 7 divided by 7, 3 divided by 7. So this is the D question, and that's all.